Hi, I'm Scott Campbell with Solve 3D.
And I'm Kevin Miller at Solve 3D.
Kevin, today we're going to talk about the floor plan function that's inside of Engine. And basically, if you have some LiDAR and you want to generate a GeoTIFF, this is the function that you would use for both either indoor LiDAR or outdoor LiDAR. And if you wanted to, you could use the GeoTIFF and just use it as a single simple map of the inside of your building, or even as a campus map, if that's what you wanted. Or you could bring the GeoTIFF into AutoCAD and use it as a base layer to generate a more complex drawing. You could even use it as a before and after comparison with aerial photos, say if you had a disaster. You could even bring it back inside of an Engine project. Where is this function found?
Yeah, so inside of our Engine workflow, we have, so I've opened it up here, we have under image processing, there's a generate floor plan function. And don't let the name fool you. Floor plan, site plan, overview picture, whatever you want to call it, this is the function to call.
Okay, we get a couple of options that we can select. How do I use the function and what are the options that I can choose from?
Sure, so just as a kind of a point of context, I just want to show you a point cloud first here that I've loaded in the Engine viewer. We have a kind of indoor facility here. It might be hard to see. There's a lot going on, lots of piping, lots of walkways and scaffolding and some boiler plants or boiler tanks in the background. So we're going to use this point cloud as a reference, but inside of Engine workflow, once you've added the generate floor plan function to your operation area, you would select that LAS file. So this is called facility LAS. And then we have 5 parameters to define. So the first one being pixel size. And this one confuses a lot of people, but essentially for every 1 pixel in the image that it's going to generate, we need to specify a value of size that is used to consolidate into that 1 pixel. So what I mean is say you have a, in this case, my facility, it's about 25 meters across from, from on the X value all the way across. So it's 25 meters wide. So when I go to the pixel size and I put something like 0.01, this is going to give me 1 pixel every 1 centimeter of my data. Similar with the height step. When the algorithm is going through and examining this point cloud, it's going to look at it from this kind of 2D top-down view, looking out overhead. Height step is going to be how far to analyze in the process of for the unit of measure for determining the density of that column of data in that point cloud. So again, I would start with a value similar to your pixel size, about 0.01. But if you want more definition, you want some more darker lines, you may want to decrease this value to get something more defined.
I think of height step as the slice that the function is going to take in the vertical data, right? So
that's right. Yeah. So percentile, I'll show you a few examples of this in a second here, but basically after calculations are complete, I recommend playing with this percentile to determine basically the overall gradient of how defined your image will be. So a lower value is going to keep more density essentially, and you'll get darker images, whereas a higher value might filter out some of those lower percentiles and only keep the very well-defined dense areas of your point cloud. So we're going to leave this on default. All right, so highest only is a selection where you can either choose true or false, and it basically describes, or when you have it true, it will tell the algorithm to only pick the highest density areas within the results. So, for example, if you have a floor plan, say an indoor floor plan, and you have a lot of walls, it's gonna those walls are typically dense in that vertical stack. So there's going to be those walls will remain. However, if you leave it false, you might get a lot of the extra things like the deaths or the, I don't know, some of the not as dense things that might be around within that environment. And kind of similarly in an outdoor environment, you might get, if you leave highest only on true, you might get a lot of the like the trees and you know, things like that, or you might have got a lot of coverage in your LiDAR data, or if you leave it, and you won't get any of the grass in that case, but if you leave it false, you're going to get kind of a mix of everything there. So we're going to leave it false in this case. And invert colors, true or false, we're going to leave this on false, but essentially when it's false, it's going to draw areas with more density in a darker color, so more black, and areas with less density in a whiter or grayer color. And true does the opposite. It does, you know, more density is going to be more white and less density is going to be more black. So then we need to pick an output folder, put in my out directory, and we're going to hit execute and execute. So depending on the size of your point clouds, this might only take a few seconds. You can see here in my case, my point cloud is about 25 meters. And since I use a pixel size of 1 centimeter, I'm getting about, you know, 2,500 by 2,500 image here. So it's pretty quick, about 10 seconds there to generate that image. We'll just go quickly look at it. So here's the floorplan.tiff. And there we go. We can get a kind of an overview of those boilers that I was looking at and all that scaffolding and those valves and instruments that were in this facility.
That's pretty cool.
And then kind of just to show you an example of the percentile, I'm going to actually run this on a different data set just to show you that it also works on some outdoor data. And this could be defined whether, you know, it doesn't really matter if it's terrestrial scanning, aerial LiDAR, or mobile mapping LiDAR. In this case, I have some aerial LiDAR versus some outdoor data. I'm going to leave this on, I think I'm going to go about 10 centimeters here, just because I know this is a rather big file. And I'll leave this on the 90th percentile again, just to, actually, let's go down to 80 here, just to mix it up. Leave this else. Yeah, that looks good. We're going to hit execute. And so you see this one's quite a bit bigger of an image, so it might take a few seconds longer to generate. Here we go. So it's going to overwrite this other one I did once it's finished.
I guess that's an important point for people to remember, is that it will overwrite anything. So you're going to want to move the results or pick a different folder every time you run it.
Mm-hmm. So here we go. Here's our kind of aerial view of that outdoor data. In this case, there's a whole bunch of buildings or houses and some trees, and you know, maybe a power line there. So I ran this at, what did I run this at? 80 percentile. I did previously run this just for demo purposes here at different percentiles. So if I load up the 80, here's the one we were just looking at. But if I cycle, you can see as I move up a percentile, 90 percentile, it gets a little lighter, you know, filtering out some of that less dense data. And, you know, 99 or even 99.9, we're getting into kind of cloudy territory there. Maybe 99 is good. But, you know, depending on your use case, this might be good or bad. And kind of as another perspective, on our website, we have a blog post about this. Here's some mobile mapping data where I did of, I believe this is a hospital facility. You can see here on the left, the 99.9 percentile where, you know, where there's a lot of points, especially on the definition of this building, the outside of this building, there's a lot of points collected by the LiDAR. It's very, very dark and you know, we basically filtered everything else out. Where if I leave this on 90 percentile, I get quite a lot more definition, a lot of noise of the trees on the outside of the collection, but I still get some quite some good definition of those buildings. So yeah, it really depends on your data, and you should play with those numbers to get something good or bad.
Okay, thanks, Kevin. That's a pretty useful function.
No problem.